We're now going to walk through each of the practice exercises, unpacking the SQL skills that you will need in three separate sections. And I've put together this checklist to help organize these required skills. First, you want to be able to produce simple SQL statements that demonstrate your ability to select fields from tables, imposing criteria with where clauses, and then sorting the data with order by at the end. And then in the next two videos, we'll work on how to aggregate data as well as query across multiple tables using joins. I've also put together this basic template to help you see the structure of a query that incorporates all of those elements and the order in which these operators need to be specified. I've included this template in the instructions to the practice exercises for your reference if you find it helpful. Let's start learning the fundamentals of SQL syntax, beginning with select. This is the command we use to begin every single query that we'll do in this class, and it directly precedes the column or field names that you ultimately want returned. These need to be specified individually and separated with commas. And as we saw in our quick practice example in the prior video, if you want to select all the fields in a table, you can use an asterisk or star. Now, SQL commands are not case sensitive, but many analysts prefer to type them in all caps for visual clarity. I'll try to do this now and then, but you'll probably notice that I'm a little bit inconsistent with my formatting. And some of this is by design so that you can see the flexibility with the coding environment. The last thing I want to note about the select command is that you can also use select distinct to return only the unique instances of the field selected. In other words, if the values for a particular set of fields are identical across multiple records, they will be returned only once. Next, we've got from, which is the clause that we add just after invoking select. And this is how we designate which tables contain the fields we're selecting. So I think this goes without saying that the indicated table must contain the columns requested in the select command, or it just won't work. And then going back to stylistic convention, you can also type each clause in a separate line, but you don't have to. You'll probably see me do it in different ways. And with select and from, these are the bare bones of what a query must contain, selecting fields from tables. And since this is enough to construct a complete query, I also mention here that you can use semicolons to indicate the end of an individual query, though these are also not necessary. Now we've got the where clause, which we can use to impose criteria on a query. In other words, we want to select fields from tables where certain criteria are satisfied, and only records will be returned that meet those conditions. You can also impose more than one criteria, separating these with an and or an or, depending on whether you need all conditions or at least one condition to be met, respectively. So let me give you a few examples of how to impose these criteria. And I want to preface this by saying that in different SQL environments, certain conventions or requirements may vary a little bit. On the one hand, that can be a little annoying to have to work with. But on the other hand, I actually think it's good for you guys to develop your technical agility, being flexible to adapt to whatever environment you're operating in. To illustrate this, I'll be honest and say that I'm recycling these slides that I've used when teaching SQL at a different university, but I've had to update them based on the conventions that dbGate Lite requires. So if you're ever in a position to be using SQL queries at work in the future, just know that most of what we do is universal, but some things are in fact platform specific. We can start with using where criteria to require an exact match. For example, for fields that are text data type, you would specify where the field name equals, and then in single quotes, type the exact text you want to match on. In this example, we appear to want to look at order information where the order ID field equals purchase order 1848. Of course, having typed that exactly as what you see there in those single quotes. Next, when you want to do an exact match using numeric fields, you just type the number with no quotes around it. In this case, where the quantity field equals 2. You can also use an exclamation point immediately followed by an equal sign to specify that a field be not equal to a given value. In this example, we'd be looking at all the people whose first name isn't Roger. Let's keep going with a couple more. You can also use inequalities with numeric fields, including dates. In this example, we'd look at employees with a salary greater than $75,000. And maybe this goes without saying, but it's important to not include a comma when specifying that number. Just type out the digits only. For date fields, the bigger a number is, the farther out it is in the future. I'll also point out that you can specify whether the values for a given field be null, in other words, empty. So take a quick second to consider, what would it mean to be pulling information from an employee's table where the field termination date is null? This would imply that we'd be looking at everybody who is still with the company, because there should be no value for this termination date field. The last SQL operator we'll consider in this video is order by, which is used to sort the data by one or more fields. So after typing order by, you specify a column, and then by default, the data will be sorted in ascending order for that field. You could type ASC for ascending after the field name, but it really won't do anything different because that method was already the default. However, if you want to sort in descending order, you would type DESC after a column name. Let's now apply these skills using the practice exercises that were included in your download materials. Before launching into the queries themselves, I think it's important to first take a look at the data model to learn the various tables in the database and the columns that we can select. I encourage you to pause the video right now and take a minute or two just to review these so that you're familiar with the data we'll be working with. Hopefully, as you scanned over this diagram, you were able to observe the cardinalities between tables. All of these reflect one-to-many relationships. So when you look at a number pair next to each table, for now, you should just focus on the second number in that pair. So going from locations to employees, we can see that this is a one-to-many relationship with that star right there. A given location can have many employees, but a given employee works at one and only one location. Since the many side of the association is next to the employees class, it hosts location ID as a foreign key. Let's also take a minute to understand the relationships between orders, order lines, and products. Typically, you would think of products being included in orders, but this would constitute a many-to-many relationship because a given order might well include multiple products, while at the same time, a given product hopefully shows up on more than one order. So in this diagram, we've gone ahead and modeled the linking table, known as order lines, that represents each individual line item for a given order. It will tell us which product is being sold and the quantity, but any other product-specific information will be found in the products table. Lastly, we can see that going from products to product lines is a many-to-one relationship, where a given product will correspond to only one product line, but a given product line ought to have multiple products. I think we're ready to now begin the exercises for that first section. Number 1 asks us to generate a comprehensive list of product information, sorted from lowest to highest priced goods. Let's go back to our database in dbGate Lite to work on that query. So let's go ahead and go on the left-hand side to add a new query. And after clearing this out, we want a comprehensive list of product information. So I will select star, meaning retrieve all the fields from the products table. Let's run that for now and see what it produces. And as we can see, we've got a comprehensive list of fields from product ID all the way to cost, but ultimately the instructions asked for it to be sorted in ascending order by price. So lastly, I will add order by price. We'll run that. And we can see that it starts with tennis balls, a baseball, and so forth. It is now sorted on the price field. We could add the letters ASC for ascending order after price and run it. but it gives us the exact same thing. Again, ascending order is the default. I'm going to go ahead and save this query as Q1. Let's move on to number 2. Now we're asked to list the location ID, city, and sales tax rate for locations in Florida. Now, I've tried to give enough information to know how to spell each of these fields and how the value for Florida will show up in the state column, but in this example, I'm going to intentionally run into some dead ends to show potential pitfalls. I'll add a new query where we select location ID, comma, city, comma, and for now I'll type tax rate from locations table where state equals Florida. Let's run that and see what errors it produces. Okay, first it tells us there's no such column as tax rate. If needed, we could always go to the database itself and go to the locations table to see how each of these fields are spelled exactly. I forgot to call it sales tax rate, all one word. So going back to this query, I'll correct that to sales tax rate. I'll try running it again. And the query executed with 0 rows returned. Well, that's interesting because I know this company operates in Florida. Let's take a look at the data one more time. But this time I'm looking at the values that state takes on. And it looks like these are postal code abbreviations. I should have specified capital FL for the value for state. So going back to my new query, I'll change this to state equals FL. It produces locations 1 and 3 in Miami and Orlando that have disparate sales tax rates. Lastly, in number 3, we are asked to generate a comprehensive list of sales support employees who are currently working. And as a hint, I tell you that this means they do not have values for a termination date. We're also asked to sort the output such that employees that were most recently hired appear first. So there's a bunch going on there. Let's take it one step at a time. I guess before proceeding, I ought to save this last query. And now we're ready to add a new one. Let's select star from employees. Notice that I didn't capitalize all the letters in from, and I've put all of this on one line for now. It might not look as pretty, but it runs the same. In this query, we need to impose 2 criteria, but I'll start with the first one, where role equals sales support. Let's run that and see what that gives us. So far, looks pretty good. We've got all this sales support staff, but I see that some of these have values for termination date. So as a second part of this line, after that end quote, I'll put and termination date is null. And let's run that. Looks like a good incremental contribution to our query here. But lastly, we were asked to sort this list so that our most recently hired employees appear first. So we can end this with order by hire date. If I run that, recall that the default is ascending order. That's not what we want, so I do have to put DESC for descending to list our most recently hired employees first. I'll save this query, and that wraps up our basic SQL statements.